Let's move on to applications of this, and then we see what next. So from here you will see that we can have what we call that. If you remember, we said an even number is written as 2n, and an odd number is written as 2n plus 1. And we said for every n coming from n. This is how we write an even. This is even. This is an odd number. So we are going to apply now this smaller concept to be able to know what to do next. So we can say, show that, this is the question, please. Show that 2 squared, can we take cubed? 2 cubed plus, this is 4 cubed plus 6 cubed plus, these are even numbers, 2n cubed equals to, we can say 2n squared into n plus 1 squared. Let's prove this. Prove that this is true. So the question here can be, if someone is to set a question here, if someone is to set a question to look for so good, someone can say that, show that, oh, let me set to you to be a standard question. Prove by, someone can say, prove by induction that, prove by induction is that 1 cubed plus 2 cubed plus 3 cubed plus up to n cubed equals to n squared over 4 into n plus 1 squared. Hence, show that this question here is true. That's how the good question can be set. That is how it can be. Prove by induction that this is true. Hence, you show that this is equal to this. So that's how the good question can be said. And because we have already this part, let's just go to this outer one. And let me show you how to do it. I think the easiest way to do it is this. The easiest way to do it is this. You see that these are, is moving from 2, is moving from 2, which is even, is going to 4, which is even, is going to 6, which is even. So what we do here, we expect that this is even. We expect that it is to go with the even number. And this is the even number we are talking about. That is the even number we are talking about. So let's try to see how we can go about it. It is easy. So your work is to just look at it critically. This is what we have. We can let that we have, this is a 2 cubed plus this is 3 cubed. Sorry, this is a 2 cubed plus 4 cubed plus 6 cubed plus up to plus 2 to power n, 2n to 3. This is the expression here. Now, because they want us to show that it is the other side, meaning that we have to move from this side, we show the other expression. So this one equals to what? I can write each When you look at the other three formula, I showed you the other three, which are these ones here. When you look at these three formula, this one, and this one, they should be at your fingertip. Now, when you try to check properly, these three, how can we write this expression given to us in terms of these three here? That's what we are targeting now. How do we write these ones here in terms of this guy here? Now, when you try to see, if you try to pull out a 2, we can get something better in front of us. And we can write it as 2. This one here can be written as 2 to power 3 times 1 to power 3. When you try to check, this one equals to this plus. This is the plus I'm moving with. This can be written as 2 to power 3 times 2 to power 3. This one is the same as this guy. Plus, this one can be written as 2 to power 3 times 3 to power 3. Otherwise, these are indices. It's like a 6 times 6 to 3, then you write you write 2 times 3, then you set power 3. Then this one descends to 2 to power 3 times 3 to power 3. It is what I'm doing. Just indices. But I'm trying to see that my formula, one of these ones here should come. Then plus up to. When I go to this one here, this one is already simple. This is the same as writing 2 times 2 to power 3 times n to power 3. Now I'm factorizing. From here, I'm factorizing. A 2 to power 3 is common. So I have 2 to power 3 is common into, I have 1 cubed here. I have 2 cubed there. I have 3 cubed there. I have others up to n cubed. Now,
excuse me, sir.
Please.
I have some question about that second one. 2 cubed times 2 cubed.
This one here?
Yes. Wouldn't it be
Please,
2
this one
cubed
is
times
yes, this
2
one
cubed
here.
times 1?
No. You are lying. Let me show you where it's coming from. You see, if I do it from here, I have 4 to power 3. This is the same as writing. This is the same as writing 2 times 2 power 3. Then I can write this one. I can write this one as 2 to 3 times 2 to 3. So I'm right, sir. I'm all right. That thing is okay. So this is 2 to power 3 into, now, from the other formula 3, this guy here, the whole of this guy, is equivalent to this is n squared over, because we are adding up to n, we are basing on the last one. If this was k, we would have used the k, but since this is n, then our formula should be n. N over 4 into n plus 1 squared. The whole of this summing will produce this guy. Then when you try to calculate, this one here is 8 and this is 4. So this one will turn into 2 when you cross n plus 1 squared. So this is the thing. That is how it comes. So I'm going to give you another question here. I think I should do. Please color this equation here. Please color this equation star. Color this equation star, because the next question I'm going to give you, color that proof you have just done a star, because the next question we are going to use it. You call it a star, because I want to use it in the next question. So let's move on to the next question, and then we see what to do. So let's move on to something good. Write this question here. Show that 1 cubed plus 2 cubed plus up to others plus this is 2n plus 1 cubed, that it equals to 2n plus 1 squared into n plus 1 squared. You show that that is 2. So you look here. You look here, please. Now, since 1 cubed plus 2 cubed plus up to n cubed equals to n squared over 4, someone is asking, it is 3 not 2. Okay, I don't know what the question you have asked, but unmute and talk to me. So look here, please. Let's first review those things. So we know 1 cubed plus 2 cubed plus 3 cubed equals to this. We know this formula. Now, the formula they are telling us, it is 1 cubed plus 2 cubed plus up to 2n plus 1 to power 3. Now, the difference here is, here they are stopping on n, here they are moving on up to the third. This is, remember, this is the odd. This is odd, up to the odd. What does it mean? It means that instead of n here, we are supposed to put this guy. That is the only difference. So this indicates to me that if I have 1 cubed plus 2 cubed plus others plus up to n plus 1 cubed, it will equal to, the formula is clear, n, this is 2n plus 1, this is squared over 4. Take n equals to n to n plus 1. That is the difference. We are removing n, we are putting into n plus 1 into this inner part. This is 2n plus 1 plus 1. Hope you are together there. Squared. So this one here equals what? This is 2n plus 1 squared over 4 into this guy here will be 2n plus 1 then plus 1 squared. This guy here will be 2n plus 1 over 4 into 2 into n plus 1 squared. Look here, please. I'm going to factorize out something and I cross it out directly. So I'm not going to show it to you. Look what the expression clearly there is a 2 which I want out, which I want to take out. So you see this is a 4. This is a 2, but this 2 it is squared, meaning that I'm going to write it as 2 squared, then this expression is squared. And therefore I will get something funny, 2n plus 1 over 4 into n plus 1 squared. This is squared. This guy was squared initially because of this, and this. This is squared here. And this is squared here. And a 4 will come there. So this will cross with this. You'll get this is 2n plus 1 squared into n plus 1 squared. So this is the thing they want us to show. Please also call this equation double star. The other one I've told you to call it star. This one I've said you call it star. Then we have the questions, of which I'm going to give some as coursework. Now you can see questions. Find the sums of the following series. So we have number 1. We have 1 cubed plus 3 cubed plus. Okay, we can say 1 cubed plus 3 cubed plus 5 cubed plus others plus up to 2n plus 1 cubed. This is number 1. Number 2. One cubed plus 2 squared. Oh, 1 squared plus 2 squared plus up to n plus 1 squared. Another one is 1 cubed plus 2 cubed plus up to this is 2n minus 1 cubed. Another one is which is number 4 is 2 times 3 plus 3 times 4 plus 4 times 5 plus others plus n plus 1 into n plus 2. So please look at these questions critically, and I'm going to do the ones I'm sure that you may not be able to do. I'm going to do this one here. This is number 1. I'm going to do that. Then I'm going to do this. This is a coursework, and this is a coursework. Number 1 is to be done by us. Number 2, us. Number 3, and number 4, it is your coursework. So let's try to move on now with number 1. Look at number one critically. You look at equation star. So me, I'm going to say, look from star and a double star. Please identify those equations first before even we do anything. You look for those equations. You look for those equations. Equation is star and the equation is double star. There is something I want you to look at. You look at those equations. Let me identify them for you here.
Excuse me, sir, you have unmuted yourself. You have muted yourself.
Sorry. Sorry. And I've said this equation here, which produced the equation star, we are dealing with even values. Now, this one here, yeah, this one here, 1 cubed plus 3 cubed, we are dealing with everything, and this is what we have proved, and this is what we have called equation double star. Those are the two equations we have seen. So you look at them critically. There is something I'm going to do with them. There's something we are going to do with them. Now, remember, equation 1 is telling us that, okay, you go on adding 1 cubed plus 3 cubed plus 5 cubed plus up to plus, this is 2n plus 1 cubed. We want the expression from here of adding these things. Remember, telling you to find the sums, it implies that you are supposed to add and another expression. Now, what do they want? They want us to give them an expression like that we have been showing. Now, remember still, I'm going to generate here a formula which is not formal. That if you are having even numbers, think you know even numbers, which are written as 2n, you add odd numbers, which are written as 2n plus 1, you must get n, the natural numbers. So this is the thing you should be knowing. Now, what do we know about the three equations we have at hand? It implies that we have this. If you are having odd numbers, must equal to all the numbers you subtract off the even numbers. Look at this formula critically. This is the same as saying equation double star. This is the same as saying equation star. This is the same as saying this equation here. Please look at that expression clearly. You ask a question. If you don't have a question, then we try to move on. Look at the expression properly. So is there any question, please, or we move on? Any question? Okay, good students. You know, I like that. So, what does it imply now? It implies that if I have 1 cubed plus 3 cubed plus 5 cubed plus up to, this is 2n plus 1 cubed, I will get the equation of all n, which is 1 cubed plus 2 cubed plus up to. I'll move until when I find this value here, that's why I say up to 2n plus 1 cubed. Then this is a single sum minus even ones. It implies that even I'll take a 2 cubed plus this is 4 cubed plus 6 cubed plus up to 2n power 3. So that is the expression there. And then when you try to look at it critically, the whole of this, we have already proved it. And it has given us something which is equation star. Can you check for me equation double star? It is where we have seen that we have got 2n plus 1, then squared into n plus 1 squared from here. Then minus this second one here, you remember, it's what we call the equation star. This is 2n squared into n plus 1 squared. And when you try to check properly, we are going to factorize out. This one and this, they are common. This is equivalent to n plus 1 squared into, this is what is remaining here, 2n plus 1 squared minus 2n squared, because this one I have factorized it out. This is n plus 1 squared into, when we expand here, I think we get something good, which is 4n squared plus, this is 4n plus 1 minus 2n squared. So this is something good, which is n plus 1 squared into 2n squared plus 4n minus plus 1. And then when I try to see this properly, I think we can stop there, because this one we may not be able to simplify it further. That is the expression, meaning that this is the answer we can submit there. But now, if you are given only this, you must derive this first, then you derive this. If you are given only this, you must derive this first, then you derive this. So that is the whatever. That is the condition there. But if you have managed to see well, then it is okay. Now, let's go to question number 2. Then I leave there with the questions to answer. So number 2. Let's see. Is it something good for me to do? What? Where is number 2 now? So can you try to see number 2? Then we try to move on with it. So number 2 is here. This is 1 squared plus 2 squared plus up to that, yes. Number 2, we have this is 1 squared plus this is 2 squared plus up to plus n plus 1 squared. Now, look what this, but now this is something funny. Look what this expression clearly. This is like we are dealing with equation number 2. But now here, they are telling us that, you see, the difference with the other expression that here, this is the same as maybe it was stopping on n squared. Now they have added n plus 1 squared. So what I may tell you to do, I think I should give it to you also, because I gave it to you already. So we are going to stop at this. You also do this one as coursework, because remember I gave it to you as number 1. Now I've added these other 2, those are the 3 numbers. So this one, if I do it, I will be doing the other work of yours. So please, you do it. You do it. Now you go to the handout. Let's conclude page 37, and then we go to the next page. When you go to the handout, remember, if I try to remind you properly, we said a cell we are adding. Now we said adding, we must get either a finite term or an infinite term. Now, we have seen what we call a finite term. And there are things I want you to remember from there. Or infinite term. If not infinite, we may not even know whether it is finite or infinite. Now, we have finished this. Let's move on with the infinite terms. And the infinite, we are referring to page 37. Sorry, page 38 at the top. On top. It is what they are saying, that we want to formalize the idea of adding. Now, they are telling you that if I have a sequence AN, I know the elements of a sequence, the terms of a sequence, I can have A1, I can have A2, I can have A3, and others. What does it mean? It implies that I can go on adding terms A1, this is A2, this is A3, plus others. So long as I'm continuously adding them, I'm talking about infinite things. Now, before even we continue further with this expression here, with the infinite, there are things we should remember. That if you are having a GP, a geometric progression, we know that sum to infinity, because we are going to sum up. Can I say that it will be 1 over 1 minus r? If magnitude of r is less than 1, probably, if I state it in a proper way, we say that if we are having a GP, we are having magnitude of r less than 1, sum to infinity, it will be the same as a over 1 minus r. But if you are having magnitude of r greater than 1, sum to infinity, it will be the same as a over r minus 1. Now, in the 2 provisions, this one here and this one here, in the 2 of them, we don't have a situation where r equals to 1, because when r is equal to 1, then this guy and this one here will not be defined. So we take them to be at that level. Also, we should know that if you are having an AP, I want you to remember that you used to take sums. So a sum of an AP is the same as n over 2 into 2a plus n minus 1 of d. You must be able to remember this is the same as the common difference, and here r is the common relation. Our a is the first term, also here a is the first term. N is the sum of the n terms. Here we are adding up to certain number n, meaning that this one here is finite, because we are adding up to a certain number n. Here, we don't have a number, therefore, we are adding up to infinity. Don't forget that where you have a sum, a finite sum, you remember you have 1 over 1 minus r to power n over 1 minus r. This is when you are having a sum of any terms. This is when you are having sum any terms of a GP. So, but what I may try to say is that you try to remember this sum to infinity because you are going to use them at certain point t, and then we shall progress with them. Now, you see that formula on top of page 28. They are telling us that if you are having that sequence 1 over 1 minus x, actually, the best way is to have a sequence clearly written as xn equals to or I can write it in this way. I can write my sequence as xn equals to x squared of n. And this is the sequence. Now, if I write it clearly, and I can start with 1 plus x squared plus and other terms. And this one here will equal to 1 minus 1 over x. Now, where this one comes from, if I try to take u there before we reach there, it is the same as just AP. Sorry, same as just GP. Where is it coming from? You see that here, your A is equal to 1. Your R will equal to x over 1, which is x. And we assume that this x is smaller than 1. So sum to infinity, it will be the same as 1a over 1 minus r, which is a is 1 minus x. This is the formula here. It is this guy here. That's where we obtained it from. But no one is going to ask you much about it. But what we are saying, our explanation is on this. If I have 1 plus x squared plus up to equals to 1 over 1 minus x, that's why they are equal. The reason why they are equal is that we are summing up them. So don't get confused. The reason why that formula is equal is because we are summing, and we are summing up to infinity. And we substitute in the formula of sum to infinity, we get this guy. That's why those things are equal. So don't get confused as why these two are equal. This is sum to infinity. This is the expanded way of summing up to infinity. So don't get confused over that. So that's the thing. And when you try to read it through, the question is, does this converge? Is it true? So the question remains there. And our target now is to know, when does it converge? When does it converge? And the techniques of testing for convergence. That is the target for I think for the next time. Converging and the testing for convergence. That is what we are targeting. That's what we are targeting. Does it converge? Does it diverge? If it is to converge, what do we follow? And how do we test for it? That is the target of the remaining bit of the subtopic. What are the methods we are supposed to use to test for convergence? Now, you should first of all know that if something doesn't converge, we saw already that it versus what? Divergence. If something doesn't converge, then it will diverge. So we don't have any way where I say converging divergence. No, it either converges or diverges. Now, our target is to know what does it mean for the cell to converge. What does it take for the cell to diverge? How do you test? Those are the targets. How do you test? And what does it take? Now, I want you to read it through definition Definition 3.46. Definition 3.46. I think we extend for just more than, just slightly 10 minutes, then we leave. Read it through definition 3.46. You'll see that if we are adding this thing here, you'll see that when a minute please before you read there, you see that x1 plus x2 plus other things can be written as this, that we are adding up to infinity, we are adding k is equal to 1 up to infinity of this is the same as xk. These ones here, they should tally. It implies that when k is equal to 1, you get x1 plus. When k is equal to 2, you get x2 plus. When x is equal to 3, you get x3 plus, and other terms. That's why we are putting this continuity component here. Now, that is the thing which may take you crazy there. You read through, and we see what next. Now, you'll see that what we call the partial sum, any partial sum, any partial sum, which is abbreviated as SN here. You'll see that of a series, which is k from 1 up to infinity of xk, is the sum Sn equals to summing up from k is equal to 1 up to n of the same sequence. Now look here, please. This is when you check this and this is the whole sum, but of a sequence. This is the whole sum of a sequence. This is the partial sum of a sequence. How does it differ? That this one you take up to n, but this one you take up to infinity. So what does it mean? What we have been doing, for instance, if we have already seen that we can say 1 plus 2 plus 3 plus up to plus n, we have already seen that this is n over 2 into n plus 1. This is the partial sum of the sequence. What is the name of this sequence? The sequence 1 plus 2 plus 3 plus up to. Hope now you are getting the difference. This one here is what we call the partial sum, that we have taken the sum of some first n terms of a given sequence. So meaning that when you go on adding terms of the first n terms of a given sequence, we call that partial sum of a set. Or remember, when you add from the first one up to infinity, we call it a set. So now you should know that this one here, in the abbreviation, you write it as sum from maybe n is equal, or k is equal to 1 up to n of the sequence xn. But our sequence is good, it is just n. You keep adding 1, like that. But now this one here is the sum from k is equal to 1 up to infinity of the sequence xn. Of what's the sequence? Our sequence is n. Why am I saying sequence is n? Because we have seen that xn is equal to n. If xn is equal to n, then it will be xn is equal to 1, 2, 3, 4, 5. You will see. Now, when you want to convert this one into a series, you keep adding these elements. And then this confirms to me that this is the sequence. So partially, I'm adding up to a certain value. Then if I add everything, it. Now we shall, now when you read through that handout, after definition 3.46, hope you are following with the handout. They are telling you that instead of writing all of this, we are going to partially write just sum. This is the, instead of writing, let me be clear, instead of writing something big like, and we just write something like simple sum xn. So meaning that when you find sum xn, I think remember I talked about it this at the beginning. I talked about this at the beginning. So when you have this, it means this. But when there is when I write like this, when I write k is equal to 1 up to maybe 6, this one of xn, this one, the moment you drop this 6, thinking that it is the same as when I just write like this, then this one is rubbish. It cannot be. So it will be wrong. That's what they are telling you. And also, now they are telling you that when you change this k, this is k. When you change this k, maybe this is the same as still writing up to 6, maybe j is equal to 1 of xj. It is the same thing as when you write, maybe n is equal to 1 up to 6. This is the xn. What you should know, this one here should tally with what is there. When you change, this one here should tally with this one, with the one which is there. So when you change, these two should change, should tally, but the meaning remains the same. So if you are free to use the first letter of your mother's name, the first letter of your father's name, anything you want. So I'm going to skip those examples there. We shall come back. And I want you to go to definition 3.48. Definition 3.48. And I think for today we stop at that point. Definition 3.48. So that's where we shall pick it. That's where we shall pick that from. You read through that thing, then you next time we shall start from there. Any question, please?